More than 15 years after its first element was launched, the International Space Station is now a round-the-clock laboratory that supports a crew of 6 working on cutting-edge science. It's currently commanded by a man who first laid eyes on this station before the first permanent crew arrived.
It's wonderful to see that the station has become such a wonderful scientific lab. And I'm so glad now to see that the station is in the stage of full utilization, conducting a variety of experiments in science and technology, educational programs, observation in astronomy, and also the Earth observation.
We don't really know what we're going to learn, but we know we have the potential to learn many, many different things, and it's almost with basic science.
Some of that research is conducted from the exterior of the station. For example, from a perch on the station's truss, the Alpha Magnetic Spectrometer gathers cosmic particles for investigators who are looking into the very origins of our universe. Other instruments look down to study the Earth's atmosphere and oceans and land masses. All the while, the human crew members work in the station's laboratories to help execute experiments in a range of disciplines, while serving as test subjects for research on how the human body is impacted by weightlessness, so scientists can figure out ways to help them adapt during deep space missions of the future.
If we want to go on to Mars or asteroids or back to the moon or even further out, we need to know what the body can handle and what it can't, where it's weakest, and how to protect the crew members from the radiation, from the weightlessness, all the effects that space travel have on the human body.
We have experiments that allow to monitor the condition of blood, the composition of different microelements in the human blood, determine the degree of bone mass loss.
The muscles, the tendons are affected, they are losing the elasticity. Something happens with your skin, with your cardiovascular system, and it adapts to zero gravity as well, and there are some serious changes too.
While tracking the changes undergone by the body, crew members are also testing a variety of ways to counteract the negative effects, and they're having some good results.
For example, ARED, the Advanced Resistive Exercise Device, basically a weightlifting machine that we have on board the International Space Station now, and it's been up there for a couple of years or so. People are coming back from space stronger than when they left in many cases, and we're seeing great improvements in strength and bone density and things like that.
But over time, they keep finding new things to work on. For example, there is now research directed specifically at changes to the eyes and to the inner structure of a crew member's bones.
We've realized now that as we lose calcium once we get in space, that some of that structure on the inner side is changing in ways that we didn't realize. And we might be losing strength in our bones even though we keep the same bone density.
We will be measuring our physiological data related to the changes in the eye and the brain due to the change in the intracranial pressure in the microgravity. Maybe we can come up with countermeasures to cope with the situation.
From time to time during their stay on board, each crew member will also work with experiments in other scientific disciplines, from research into basic physics to learning about how plants grow in space, to the development of new technologies. On top of that, crew members have day-to-day responsibility for keeping the station maintained and running in good shape, and for handling as many as 5 visiting vehicles.
That means that we will be seeing cargo vehicles, unloading them, loading them with trash, seeing them off.
That should include the final European Space Agency automated transfer vehicle, due to arrive during Expedition 40. That increment begins in mid-May, when Wakata, Turin, and Mastracchio come home, and Swanson becomes commander. Expedition 40 welcomes 3 more crew members at the end of that month. Veteran station crew member Max Sarayev, and first-time flyers Reed Wiseman of NASA and German astronaut Alexander Gerst of the European Space Agency. They'll continue the mission together, including making as many as 4 spacewalks from the U.S. and Russian segments of the station, until Swanson and his Soyuz crewmates return to Earth in September, wrapping up their contribution to an ongoing mission of exploration on this vehicle, which has already lasted more than 15 years.
So everybody's always taking this risk just to go explore, see what else is out there. Maybe it's for science, maybe it's just to get another land, so get more resources. Whatever it was during history, they always went off and did stuff. And I think it's still the same idea for us.